Hey, hi everyone. Welcome to next Gen AI with Sai YouTube channel. So today we are going to see about one of the protocol that is model context protocol. Uh, Nowadays, this model context protocol is making some noise. So I thought let's make a quick introductory video on this. So I'm going to cover a theoretical part, uh, that is what is model context protocol, why we require so, and then at the end of this lecture we will see a demonstration, a kind of a hands-on, so that I do not want to limit this lecture only to the theory, but if someone wants to use this, how one can use with the open source. So I'm going to use one of the open source model, uh, that is Quen from the Grok platform, and do some kind of experiment with this. So recently Langchain has also done the integration with the MCP. So we will use Langchain for this demonstration. Okay. So before I'm explaining this model context protocol, let me do kind of let me touch upon some of the history. In back in 2021 when the ChatGPT has released, we were only do some kind of question answering through the chatbot, right? And then after that they come up with the some rack capability so that you can upload a kind of files and do question answering. Then they supported something better, that is function calling, so you can integrate through API, do kind of some function calling, and then you can associate it with the some external tools. And then 2025 is something about the agentic AI. So you wanted to execute different tasks through agent, and this agent is backed up by or supported by the LLM. Now the situation comes that each and every industry wanted to a- accomplish, or I can say try to connect with the LLM and accomplish their task. And now the major problem is that each and everyone trying a different approaches to somehow use this Gen AI with their platforms, right? And there is no standard way how to utilize this LLM capability. So the cloudy team has come up with this, Anthropic cloudy team has come up with this kind of protocol, that is a model context protocol, and it gives a way or standardized way to connect the LLM to a path. Okay, so we'll go deep down in this, but I hope I explain you the kind of provide you context where we are going. Okay, so let's understand what is MCP. So MCP is an open source protocol that standardize how application provide context to the LLM. As we know that LLM is able to answer if you give some context. Generally LLM does hallucination, but if you give more context, it gives appropriate or at least nearby result that what we want. So the major problem, how we can give the context, right? Through some standardized rack, definitely, but there is not a exact way to do this. Okay, and then MCP comes the way to provide a standardized way how you can connect a LLM model, right? Let's say this is my large language model to outer world. So you can resemble this MCP something like a USB-C protocol, USB-C port, sorry, not protocol, port. So as you know that nowadays all the machines, uh, be it laptop or the computer or the your phone, has come up with the USB-C port. What is the advantage with this C port? You can connect your devices through the same port to your charging, or for the data transfer or for any kind of audio or video kind of external devices. So only one protocol helps to solve many solutions, right? So when you go with this kind of laptop, you can use the same port for different purpose. The same way, the Anthropic has come up with the same thought process. If we provide a common way to access external world, okay, then we can solve the problem, right? So you can resemble that the MCP is nothing but your USB-C port to AI application. And when I say USB-C port to AI application, it means a standardized way to connect your AI models to different data sources and the tools, right? Now I hope you understand what is MCP is all about. Now let's go to the next part to understand the general architecture. Okay, so before that, let's talk about why we require MCP. MCP helps you to build the agent and the complex workflow on top of LLM. Okay, because nowadays you can also build the agent, but the major problem when this agent is associated with tools, how you can integrate this agent along with tools to the LLM. There must be a way, right? Let's say you have your machine here, but there are some of the applications are running on the client side, right? Now to get those information from client to LLM, oh, sorry, from server to your client machine, they have to go through some process, right? Through some API calls, through some methodology, then only your LLM, then only you will able to fetch the some context from the server to the client, right? And they many people have to write the codes, or you can say the shell script or the command line script, or many other, the pipeline way YAML file they have to write down, and then only they able to provide the context. So everyone has to follow a different and the customized way to do this. So to have the common way to reduce this effort, we require MCP, right? So LLM frequently need to and as we know that LLM is require a integration with data and tools, otherwise it is not possible. So MCP provides a way. This it, it has a growing list of pre-built integration so that you can directly plug the LLM into that. So today we are not going to in depth what are the pre-built implementation we have, but there are during the hands-on we will see how you can call a simple Python file which is on the server, or a simple API call. Let's say there is a server which is running on the web on HTTPS protocol. Okay, how we can access both the things, okay, from the client, right? So we can see there are some pre-built integration is available. Then also it has a flexibility to switch between the LLM provider and the vendors. So let's say you have multiple LLM providers. Now today I'm not going in depth that which LLMs better in which kind of activity, but generally everyone knows, and at least now the understanding or the that kind of maturity comes that everyone knows which LLM is good for what kind of task, right? So sometimes they want that complex task has to be performed by some kind of reasoning model, and some of the simple tasks they want a small distill model can be performed with the lower cost. So to they wanted to switch. So this kind of flexibility is provided by the MCP. Third, the best practices securing your data within your instance. So when we work in kind of enterprise solution, we know that there is so much security restriction. You cannot lift and shift your data, right? Where you are this LLM or the client thing run. So they have to follow the security process. So to overcome this, you no need to do this. You can secure your infrastructure, and just through some API call you can send this data, okay, with the definitely authentication and the authorization process. So that is the three reason we require MCP. That the first, that it has a growing list of pre-built integration. You can use this to integrate with the LLM. Also second, it provides a lot of you can switch between the different LLM providers and vendors, and it has a best practices. You can secure your data within your infrastructure. Okay, so this is the importance of MCP. Now let's go to the general architecture, how MCP look like. So there are three I can say uh, 3 to 4 terminologies that you should aware about that. The first is that the host. Okay, now when I say host, uh, this host uh, is a program where you have different tools like Claude, IDE, or different AI tools you have, where you are hosting all these development tools. Okay, the second is the MCP client. So there can be a possibility that you have a host with the MCP client. Okay, so this MCP client maintain the one-to-one connection with server. Now you can see this is a MCP server, MCP server A, MCP server B, MCP server C, and it has one-to-one connections with different servers, and this connection through MCP protocol. Okay, now how you can access different MCP? We have some kind of methodologies like STDIO or SCC. I'll come to that point in some time. But through this you can connect to different server, and this server has some local data source, right? So this local data sources, that means it has some files, databases, or services, right? Similarly, some MCP servers can have some web API on which they can access the remote services. So these are the system over the internet, okay, that you want to access over the API. So this way it is also a possible, means it is hosting some web API. Okay, so this is the general architecture. So three terminology you should remember, that is the MCP host. So what do you mean by MCP host? The host, which is something, a program that hosting the IDA tool, AI tool, or the desktop tool that you wanted to access a data through MCP. Okay, then MCP client is the, you can say, it maintains the one-to-one connection with server. It's a protocol. Through protocol, MCP client is a protocol client through which you are maintaining the one-to-one connection. And the MCP server is the lightweight program, you can say, that expose the specific capabilities to standardized model context protocol. So each server has their own capability, right? Let's say this server has some capability to access a database file. This server has capability to access some other file system. So each server, with the lightweight program, you can expose the data to the client through protocol, right? And then you have local data sources. So data source is something that it has a kind of files and databases. And then we have the remote services, which is something the you can have external system available over the internet through API, uh, with that the MCP server. Okay, so this is the general architecture about the MCP. Now let's, now this is the what we understood. It's a bit kind of a general architecture, but if we have a simplified nature, then we have, let's say this is a host. Okay, and where we have our MCP client is configured, and there is a transport layer. Let's say there is a server processes. So MCP server which holds a server processes, and through transport process you are executing or you are accessing a data. Okay, similarly, uh, you can have, this host can have multiple MCP client. It is not necessarily that only one client is required. You may have multiple clients and you can access all these server processes through the transport. So it maintains the kind of one-to-one connections. Okay, so this is what about the theory. Okay, and we'll try to understand more things as when we execute. Okay, so this is one of the architect diagram I have captured from the one of the Medium article, just to give you the one more context, that as you can see that we have a browser MCP client. It connects to the MCP host where our cloudy and the cursor like program are executing, and we have MCP server. They are trying to access the resources through web API or some file system or the middleware. Okay, so MCP client try to access the data through server, okay, and use this kind of tools to execute the things. Okay, so again the same thing, right? Okay, so let's uh, do some kind of hands-on so that you will understand it better. Okay, so in for today's demonstration, I'm going to use the Jupyter, sorry, the VS Code. Okay, so I have done some little bit uh, pre-work so that just to save our time. Okay, so we have, these are the requirements. So definitely you will not require MCP. I think other things it's fine. Okay, though we are not using lang, okay, we are using LangGraph for some of the things, protocols, some of the method that we wanted to use. That's the reason we are using this. Okay, so if someone don't know how to set up this, you can just create a folder. You can do Python -m vnv.vnv. Okay, this way it will create the automatic virtual environment. So I want this specific library to be configured in this specific virtual environment. That's the reason I've created virtual environment. So all my libraries, when I do uh, pip.r.requirement install.requirement.txt, so all these libraries getting installed on the virtual environment. Okay, so I'll uh, share my GitHub repo for your future reference. If you wanted to do it, don't worry about it. Okay, so let's start the building these things. So first of all, let's we start with the server. Okay, client we will do it later, but let's first uh, try to implement the server. Now the program that we are going to implement, we are going to use the lang we are going to use a hands-on tutorial that Langchain has given. So I'll share that link also, so you can refer the program from there. But let's do it now so that we will get a bit understanding. Okay, so before that, now I have only one machine, so you consider this local machine itself as my server and plus my client also. So as I don't have different machine to showcase. Okay, so let's say that I have server. Okay, so I'm going to create a server folder here. Okay, under the server I'm going to create a script. Okay, so let's say I have script something log something like that, math server. Okay, .py. So you can imagine that there is a server where there is a script called as math server.py, and you have LLM, right? So you can consider that I want to use my server where I have done the script of calculation of maths, and it's a bit complex, though we are going to do a simple maths here like addition and multiplication. But let's say there is a request from the client that they wanted to do some kind of maths. Okay, and to perform this maths, the script is already there, but it is on the remote server, right? So you want some way to connect your client or this IDE where this host, so we have this host, right? And on host this ID is running, and we want to connect to server through client protocol. Okay, so I'll explain you how you can do this using this MCP library. Okay, so just a second. Okay, okay, now how you can do this. So to achieve this, so please do it with me. If not, you can just first look at and then you can just copy paste. Okay, and then try to run it. So first of all, I have already installed this thing. So I want, as this is server, so I'll go to the MCP dot server. Okay, now one more thing before that, you can achieve through this different SDK. So MCP has provided, so the Anthropic team has given SDK in the Python language, TypeScript language, Java, and Kotlin. Okay, so whatever the language you are comfortable, please use that and try to implement. So today we are only focusing on the Python. Okay, Pythonic way to achieve this. So as this is server, so I want MCP server, then fast MCP. Okay, yes, fast MCP, and I want to import fast MCP. Okay, now let me initialize this, and I'm going to say my fast MCP, and I want to give the name to this server, that is math. Okay, it's optional but it's better. Okay, let's say math. Okay, so now I'm having this server of with the name is math. Now when I done this, I want to I have a function. So let's say there is a function that I want to execute, say a int comma b int. Okay, and I want to return this in int format. Okay, and what is the return? I want to say a plus b. So whenever there is a method to addition, so I want this function to be utilized, right? So now this function is a tool, right? So to achieve this, I'm going to use the decorator function of MCP, and I say tool. So what happened with the due to this, so this function will act as a tool for this server. Similarly, we want a multiplication to be happen, so let me just copy paste it and say multiply. Okay, multiply. Okay, a and let's say into. So here we are saying add two numbers. Okay, and here we are saying add, sorry, not add, multiply two numbers, right? And then we are returning this. Now once done this, I'm saying if name, sorry, if name equal to main. Okay, and I want to run this. So MCP, we call the method called run, and the transport protocol we are using call as the stdio. Okay, so what do you mean by stdio? Stdio is the standard input output. So there are two protocol, as you can see, stdio, that is standard input output, and second is the SEC, that is secure accessing the information. So let me just give you some information on that. Okay, that is the server sent protocol, server sent event. So whenever, what is the difference between the standard input output and server sent events? So standard input output is basically useful if you want to enable a communication to standard input output, and there is a local integration is there, and you want to execute through some command lines. Okay, so you want to building a command line tools, or if you want to do local integration, or you need a simple process communication, or you want to working with the shell script. Okay, so when we going to execute, you will understand. So what I'm trying to say, that I want to run execute this program through shell script or through command line. So if this is the situation, then I'm going to use the protocol call as a standard input output. But let's say there is a server, okay, that also we are going to implement one more server where I can show you how you can do this. But there is a server where that API is running, right? The web API is running, okay? And if there is a server client streaming is needed, so every time you want that the server is updating some information, okay, this kind of streaming is needed. Or you wanted to work with the restricted, you don't want to everything to be accessed, you want some information only be accessible through some kind of port. Okay, if this is the situation, then you are going to implement the transport method called as a server sent events. Okay, so don't worry, if you're not, I'll explain you with the one more server, that is weather server pi, then you will understand. But for now, let's have this math server. Okay, so this way you can now the our math server is ready. Similarly, we want a client to client uh, things to be ready, right? Client protocol needs to be ready. So let's say a folder, say client. Okay, and under the client we are going to have the client things. We are going to write the client program here. So let's say client.py. Okay, now during the client.py we require few protocols, few libraries to import. So let's say from MCP, okay, we are going to import client session, okay, client session, and we want std io server parameters, okay, because we are going to access the server parameters through std protocol, right? Similarly we are going to access the from mcp dot client, right, and dot stdio, and then we are going to import the stdio client. So these two things require. But for the reasoning capability, so we are going to use langchain for this. So we use some methods from the langchain. So from the langchain mcp adapters dot tools, we import the load mcp tools, right? And here we are going to use the react agent from the lang graph. Okay, so from lang graph to have the reasoning capability. So LangGraph rebuild, import, and then create React agent. Again, as we are using the open source model and we use the Grok platform, so we are calling the LangChain from the LangChain Grok import chat Grok. Okay. Similarly, we wanted to access a key which we have set in the environment variable. Okay. So I'm going to use the from dot env, okay, import load dot env. And also we require, so this is a asynchronous process, so we use library call as a async. One second, async. Okay, so we will use this. Now once done this, now what first, so we have imported all the required libraries. Okay, now we are going to say load dot env. So my API key is loaded. We want model here, so we will use the model, say chat grok. So this LLM model that we are going to use, say model that is equal to the Qwen. Okay, Qwen 2.532b. Okay, now we have this chat grok model, and now we want some parameter to be passed. So what I'm looking for, I want some specific. So when I calling, I want some method, some math server.py has to be run. Okay, so I say server params. Okay, yeah, server params is equal to std, yeah, stdio params. Okay, and in this I want the command python to be executed. So I say command. Okay, now remember, my the math server is going to run in same server, right? And as I know, my all mcp package is been installed in the virtual environment. So the I want the virtual environment python exe should run. So I can go here, okay, then script, and there is a python exe is there. So you just say copy path and just paste it and say, as I'm using Windows, so I'll say R here. Okay, what I'm going to do, R, then comma, Okay, if you are using Unix, so you just copy and paste, require to say are there. And I want to run execute the math file, right? So for that I'll go to this server, say right click, copy relative path. So I'll say double quote, copy relative path. Now my server parameter is done. Now I want the async methodology to be completed, right? So I say async def main. Okay, in this main I'm going to call the method call as the, so there is a way we want to call the stdio with stdio client, right? So let's say async, right, with stdio client. So we already have stdio client, right? So let me just copy this. Okay, I mentioned with async with stdio client, and in this I'm going to pass this parameter server params, and then I want this as a call the read and both write. Okay, so I want to read as well and also do the write function. Again, now I have made the session with the server. Similarly, I want to have the client session too. So I will do again, I'll say async with client session. So, okay, so it's pop up there. Let's use that client session, and through the client session also I want to do the read and write, right? To the read and write. And how I want to read and write to the session as a session. Now once this done, I want to initialize the session. So let's say initialize the session. So I say await and session dot say initialize. Okay, so now my session is initialized. When the session is initialized, I want to get the tools. So I say get tools, and I say tools is equal to await load, and I'm going to use the LangChain capability for this. So load MCP tools, and I will pass the parameter called session. Now once done this, we want run this agent. So I say create and run the agent, and for this I'm going to say agent is equal to create, and now this time I'm wanted to use the LangGraph reasoning capability, reacting capability. So I say create react agent, and I'll pass the two parameter. One is the my model and another is the tools. Now once I have my agent is created, I want to get the agent response. Agent response. In this agent response, I say await because it's a asynchronous process. Agent dot, I call the method called AI invoke. Okay, so I'll say AI agent AI invoke. Yeah, come AI invoke, and I want to pass the as normal that what we are doing, something called as a message. Okay, in the messages, and in the messages I want message something like what is let's say 3 plus 5, right, into complete bracket, and let's say into 10 plus 1 plus or 1, 10 plus 1. Let's say I'm passing this message. Once done this, I'll say return agent response. Okay, return agent response. Yeah, correct, agent response. Now we have this, let me lower this. Yeah, now we have this async methodology created. So what we are trying to say, we are setting up our session with server as a read and write, and also we are setting up session with the client as a read and write. Initialize, we are passing the tools as well and model as well, and we are sending the message. So I want the addition and multiplication capability. I want to utilize the addition and multiplication capability of our math server. Okay, so let's do this. And let's say uh, I want a method like if, similarly like name, okay, equal to main. Okay, if name is equal to main, then I want the result and call this asyncio dot run. What is the method name? The method name must be main. Okay, fine. So let's say main. Okay, we'll do one thing. Let's say this is the input. Okay, let me say input. Okay, fine. And we'll say put is equal to something like this. Okay, okay. And once this, I want to print the result. Okay, and here while printing the result, I want something our standard we are doing, because I want just a message. So message, I want to fetch the last message, and I want just content of last message. So this is the standard we are following. So let's say we are, I think, done with the basic uh, MCP things. So I hope now you understood what we have done. We just build the a client machine where we are client protocol through which we are accessing the server. Okay, using the LLM capability, right? And this is the standard way we are doing. Okay, so let's run this. Okay, so let's say copy the relative path, and I say Python and run this. Let's see what is the result. So meanwhile, the range 3 plus 5 is 8, 10 plus is 11, so answer should come as 88. Let's see what the answer is coming. Okay, so sorry, we are not passing the input. Let me pass the input. Okay, let's do this. Okay, so we are getting some error that the tool decorator was incorrectly forgot to call it. Let me go to the tool, call MCP tool. So, oh, sorry, we correctly call. We should say MCP tool, and yeah, right. Let's make in. Okay, so I think it takes depends what is the problem. Okay, so we have messages. I think it should be messages and not the message. Mm-hmm. Okay, fine. Otherwise, it should not take too much of time. Okay, I think, yeah. So great. So we got the answer. 3 plus fly into 10 plus 1 is 88. So let's just print the result to understand what that it comes. Okay, so just to get the uh, idea about this. Okay, so what, how they are doing the reasoning. Okay, so to get the internals working. So let me just say print result. Okay, and let me execute this, and we'll go through the the output we are getting. Okay. Okay, great. So here we got the result. Now, if you look at, we have the message. What is the 3 plus ply additional core? Okay. During the tool call, goes to this function name add, right? So we have these two argument. The type is function. Then again, we have this argument add, and this is a function. Then after that, there is a one more thing, like we have uh, so 3 plus 5, we have 8, right? And the 10 1. So we have two things, right? So we have this input 3 plus 5, 10 plus 1. So they are doing addition first, right? Both of these, and then after that they are calling a multiplication of 8 and 11. Then after the multiplication, the answer is done here, something like that. Then the model name, see, we are using the model name of Quen. Okay, great. So we are using that model. Then tool call, okay, add, then tool call name 10 1, call tool call. So here we have tool call, we have multiply, right? Tool call, great. So yes, so answer is there. And then finally we got the answer, something here is the 88. I hope you understood how we are getting this answer, right? So let's let's go to the other. Okay, let's suppose we have something called as a weather uh, protocol. Okay, let's say weather. So we have something called as a server weather. So as I mentioned, the client has one-to-one connection. So let's add one more, not in the server side, but on the not client side, on the server side, we have one more server. Let's say weather server. Okay, and in weather server, we are going to write a thing. Okay, now what I'm looking for, based on my prompt, it should choose what server they want, right? So let me write the problem. What is the how my weather uh, look like? Okay, so I have already written this thing. Just to save our time, I'll copy paste here. Okay, so just to save our time, so we have fast, again as I mentioned, fast MCP weather. And let's mention that there is a method called as get weather, and we have API for this. But just as I don't have any API, so we just return the message that it's always sunny in the New York. And here I may use SEC, that is server state event. Okay, so whenever there is an event, this protocol we use. So you can imagine that this will work as a server client connection. Now, what is the difference between this math server and this server? In the math server, we are executing some particular functions, right? But the web server is a something where you accessing. So the web server has a access to remote server, and from there they are getting the information. So in this way, and as it's a web server, so we need to run this before executing the client. If the server is down, you cannot access the data. Okay, so we will run it later, but first of all, let's we need to modify something in the client side as well. So what are the things we are going to modify? In the client side, we have this standard IO client. Now the standard IO client will not work here. So as we have multiple clients, multiple server, so we need to modify this program. Okay, so let's this thing, and we want to modify with the, I want the main again, but here we want something different. Okay, so for this, I'll again do the kind of bit copy pasting just to save our time. Okay, and let me comment this so that you can refer future if you want. something like this. So what we are doing here, we want, okay, and we also require to import the multiple MCP client. Okay, and for this MCP client we want something package from LangChain. Okay, LangChain MCP adapters dot client and import the multiple MCP client. Now when I do this, so we have multiple MCP client, then we have math. In the math, now you can see we have something in math server mention the math, right? So we have this math. Okay, so we written in the dictionary format, and in the weather we have this weather. Okay, so math, we have this command that we wanted to execute it, something similar. Now we have this server, so we just need to say, we copy this, copy relative path. I think, yeah, it's the same server, math server.py. The transport methodology is stdio. Now we want to access the weather server which are running in this localhost 800 SEC, and the transport is a SEC. Now I want to pass the message, right? So I have initialized with the client the same, that is create react methodology, and the agent AI invoke as a input, and this is the response. Now let me copy paste this as well, so that we have the, okay, or let me run this first. Okay, so we have the same thing and we wanted to print the result. Now instead of printing this whole result, let me comment out this and just do this. Okay, but before executing this, let me run the weather. Okay, so we are started the our weather server first, otherwise our request will fail. Okay, and now, or let me run this first. Okay, weather command, because we have already seen this. So what is the, okay, so ask the client what is the, I ask this client what is the weather in the NYC. Okay, and let's run this now. Okay, so let's wait and see what is the result is coming. So it should give this answer that it's always a sunny in the Newark, because that's the what we have the return. Okay, so it's, I think it's trying in the backend. So it's again depend on the what kind of uh, you are using. So it is saying that the weather NYC is reported to be sunny, and this is what something we have. So as we are using LLM, so LLM just refine the return that they got from the function. Now let's ask this something different question, which is not, now you understood, right? We have two server here. One is the math server and weather server, and it has a reasoning capability to call the specific server depending on the inputs. Now let call me the maths. Okay, so we have other inputs, so let me comment out this. Okay, and let me just do the comment. Now this way I'm just going to ask a simple, let's say 3. Okay, into 3. Okay, so we have, yeah, correct. So let's run this now. So answer should, we should get 5 plus 3 8, into 3 like 24. Okay, it's a bit taking time, but generally it should not be. Yeah, so answer is 24. Great. So I hope you understood how you can run MCP server locally if you want to do demonstration, and how you can scale it, right? I hope I'm able to give some explanation so that you can kickstart. I will push this code to the GitHub so you can utilize, run it locally and test it out. In upcoming video series, we will go more in depth and try to solve a bit more complex problem than this and see how we can utilize MCP in our day to day or in the kind of big complex issues. Till that time, thank you so much. Keep watching, keep like, share, and the subscribe. Thank you.